Ladies and gentlemen, welcome. I'm Deputy Chief Editor of Bulletin of Chinese Academy of Sciences, Yang Liuchun. It's the second lecture on theory and methodology of think tank. Our speaker today is Professor Pan Jiaofeng, President of Institutes of Science and Development, CAS. With the in-depth exploration of think tank construction, China attaches increasing importance to the rational development of think tanks and high-quality research results. However, the existing think tank research usually focuses on a part of a think tank problem, lacking rational thinking and cognition of the whole process of think tank research. To this end, Pan's research team started from the three dimensions, including research process, think tank orientation, and methods and tools. Based on this theory and methodology in think tanks, a three-dimensional theoretical model in this is proposed, and they deeply analyze the model from different views, including the front view based on research process and think tank orientation, the top view based on research process and methods and tools, and the left view based on methods and tools and think tank orientation, so as to further explore the systematic methodology of think tank research to contribute to high-quality think tanks in China. Professor Pan Jiaofeng's lecture today is about 3D theoretical model in this. Please welcome.
Hello everyone. Today we are going to focus on the 3D theoretical model in DIIS. In 2017, we proposed the DIIS method for think tank research. It indicates that think tank research includes the links of data collection, information disclosure, comprehensive judgment, and solution formation. And in this process, the links of data, information, intelligence, and solution should be with the orientations of problems, evidence, and science. In each link, we need different approaches. Based on these thoughts, we establish a DIIS 3D model with three dimensions, including three orientations, four links, and methods and tools. This model can help us better use the DIIS method. For different problems, stages, and links, we can adopt different methods. In fact, the DIIS method in that sense is like a toolbox, instead of using one tool to solve all the problems. That's what we are going to talk about today. It's about the 3D model of the DIIS method, which is gradually refined in the long-term practice of think tank construction and policy research. Let's review the construction of China top think tanks. Since 2015, it has entered a new period of rapid development. The central government issued the opinions on strengthening the construction of new types of think tanks with Chinese characteristics, which made clear the role of think tanks. That is to support the governance of the country. In 2017, the state issued the construction plan of National Science and Technology Decision-Making Consultation System. In this plan, the Central Committee pointed out that we should build a national science and technology decision-making consultation system and top think tanks. So there are higher requirements for think tanks. In 2017, in the report of the 19th National Congress of the CPC, the General Secretary clearly stated that we should strengthen the construction of new types of think tanks with Chinese characteristics. We can see that the requirements for think tanks are consistent and the demands are getting higher. Then, new type think tanks should produce high-quality results, which urgently need scientific theory and methodology to understand the future trend of science and technology development. Then, they can offer forward-looking advice and systematic solutions to promote China's innovation-driven development and serve for decision-making on major issues. So think tank research is very important, including both policy value and theoretic value. Regarding policy value, in the context of complex problems, the mechanism of specialized research forces participating in decision-making in China is not yet sound, and think tank research with decision-making value is lacking, which urgently calls for think tank research. In terms of theoretical value, think tank is an important part of the national decision-making consultation system. The research on the theory and methodology of think tanks helps to increase the level of think tank research, expand the scope of concerns, and better play the role of think tanks. So think tank research is important for themselves, and also for the problems of their concern. The think tank research has been analyzed as a whole. From theory and methodology, China's think tank research is actually still weak. The current research regarding orientation, role, model, and evaluation still learns a lot from the overseas. Besides, our current research focuses on introducing overseas think tanks and discussing the construction of domestic ones, lacking the deep research on theory and methodology. The existing research always concerns parts of think tank problems without the cognition of the whole process, depending on the systems theory, and is highly repeated, short of consistency and fragmented. Actually, the study of theory and methodology with systems theory, globally speaking, is also in need of development. Based on our practice and understanding of these problems, we focus on the whole process of think tank research. Depending on previous research on the DIS method, a 3D theoretical model of think tank DIS is established. It indicates that think tank research is actually guided by the orientations of problem, evidence, and science, with the links of data, information, intelligence, and solution. And in such a process, at different links and stages, aiming at different problems and requirements, we adopt corresponding research methods. These methods can be categorized into quantitative and qualitative ones, as well as comprehensive methods combining qualitative and quantitative ones. Then when we face a think tank problem, we should use a 3D theoretical model. That is, in the case of a problem orientation should guide the links of data, information, intelligence, and solution throughout the whole process. And in this process, we should value evidence, which are objective and true. And throughout the study, we should value the application of existing scientific knowledge, scientific theories, successful experience, and also scientific methods. In the process, we choose different tools in various links, and based on the whole research process, we determine the method. So in that sense, the DIS theory and methodology can help us to choose and use tools scientifically. In a sense, it's also a method toolbox for solving problems. When regard to the process, the link of data is collecting relevant data comprehensively for the research problem, so it is problem orientation. On this basis, professional data mining, cleansing, and analysis are needed. Then objective cognition and knowledge are formed, which is to string pearls into a chain. If we think of data as pearls, the link of information is actually a process of value discovery, and the data, underlying mechanisms, and trends are reviewed. Then objective cognition provides a basis for the link of intelligence. On the basis of fully disclosing information, we need to organize scholars in related fields who are also related to our understanding of the problem. We must select those who are leading experts in the field relevant to the problem, and there can be no missing. These experts get together for judgment, and then we can gain new understandings, frameworks, and ideas. After that, for the problems to be solved, we can propose solutions and policy recommendations to provide high-quality and constructive research reports for macro decision-making. Therefore, think tank research contains links of data, information, intelligence, and solution. Then think tank research can be scientific and standard. The whole process is actually tightly coupled to the three orientations and must be under the guidance of them. Research does not start from data, but from problems, which is the illustration of problem orientation. It requires think tank research to start from problems, and these problems can be realistic. and future predicting strategic and policy problems that may have a major impact on the future. So problem orientation is throughout the whole process of DIIS research. Evidence orientation demands that any judgment should depend on evidence that are persuasive and objective facts, with scientific evidence and data as the support. Instead of talking generalities, science orientation means that research should follow the rules, and those rules are related to the existing scientific knowledge, so we should value the existing research. Scientific research methods and tools also manifest science orientation, which must be paid attention to, because comprehensive and complex problems in different research stages need various methods, and each method has specific conditions to avoid fallacies. If a method is adopted regardless of conditions, some absurd conclusions might come out. In different stages and for different problems, the specific methods combined with existing scientific knowledge can establish a systematic study of complex problems. This is the threefold purpose of science orientation. Moreover, in the aspect of methods and tools, quantitative analysis methods and tools mainly describe the values and laws of research objects for further research. Quantitative research needs to abstract the problem into a quantitative one. If the problem can be described quantitatively, it's relatively definite, and the relation among key elements can also be described. So quantitative analysis is workable based on quantitative analysis methods and tools. Then quantitative analysis is concrete to a great extent, while qualitative analysis abstracts and summarizes the features and laws of research objects for think tank research. Think tank problems involve multiple disciplines, fields, and aspects, so not all the problems can be quantified. This requires a macro view in the overall problem or in a system to analyze the features from description, finding trends and directions. It's also about something regular. Instead of fine depiction, this is qualitative analysis. Besides, comprehensive analysis analyzes the problem in a comprehensive manner. Quantitative analysis is performed to depict the problem, and then combined with qualitative analysis, a systematic study is formed. Therefore, we can also divide the methods and tools into three categories: quantitative, qualitative, and comprehensive ones. And every method and tool has applicable conditions, which are the basis for selection. Those conditions are also related to the four links and three orientations in the specific analysis of problems, which is the reason for a 3D coupling. We just mentioned that overseas, especially famous think tanks, value innovative methods and tools, but they still lack systematic methodology. The overseas think tank research started in the early 1970s, emphasizing the rigor of scientific activities, the credibility of research results, the rational application of research methods, and their innovation. The research methods of overseas think tanks are mainly based on the basic data statistics, combining quantitative analysis and experts' experience. These famous think tanks have their own databases, such as OECD, World Bank, and RAND Corporation. Databases adhere to the research direction and focus. Through constant accumulation, they can provide data support, with basic data to form a database. Also, tools for data analysis are developing. For example, the R programming language for statistical computing by the Brookings Institution often processes the information automatically. Computer-assisted personal interviewing extracts the key features of interviews to strengthen the scientificity. From method models in three categories, famous think tanks have famous research methods. For example, Quantitative analysis includes result measurement, of which Science Map Survey explains the knowledge structure of science. It was devised by the National Institute of Science and Technology Policy of Japan. So the precise planning of Japanese science and technology is related to their useful methods and tools. In addition, NISTEP has a comprehensive analysis method, the Science and Technology Foresight Method. Japan's science and technology planning gives priority to science and technology foresight, through which they predict future science and technology trend and technological development. The planning on that basis is much more scientific and feasible. Quantitative analysis also includes the hype cycle method invented by Gartner, a consulting tech giant in the world famous for its hype cycle method. The method reviews information technology in terms and maturity, which is valuable to its industrial application and researchers grasping frontier. In the quantitative analysis methods, the Delphi method in Rand Corporation is expert survey in nature. People's ideas are subjective rather than objective, because each expert has own judgment. How do we summarize the greatest consensus to deliver the expert team's common view of problems? Such common consensus largely unveils the essence of problems. Thus, an expert survey method was developed, which is widely used especially in aspects like technical foresight. Uncertain decision-making analysis is another famous method, because many think tank problems are uncertain in future development. As mentioned before, the 6 features of think tanks include uncertainty. We need to deal with uncertainty and find the certainty from it to reduce its impact. Moreover, the GAME method is a comprehensive analysis approach. In policymaking, the needs of all the stakeholders should be comprehensively considered. So, policymaking is the game between stakeholders to find the optimal strategy. World-famous companies can make reports of high quality and high level, which actually thanks to their scientific methods. China's research methods shift from qualitative to quantitative ones, but lack a systematic model for comprehensive analysis. In the early stage, we focus on qualitative methods. Starting from the 1990s, in the early stage, China's think tank research focused on qualitative research like the historical review and case study of the international methodology. Historical approach, comparative approach, and expert review were major methods at that time. Since the 21st century, China's research methods have gradually been shifting from qualitative description to quantitative analysis, with major methods like statistical analysis, text mining, and analytic hierarchy process, showing its scientific evolution. However, different methods are applicable to different conditions. World-famous think tanks methods were proposed to solve difficult problems in the research. That's why they were invented. These methods have their applicable conditions and call for a systematic model to combine these approaches. So our 3D theoretical model of DIIS is given to try to solve this problem. For example, let's combine think tank orientation and research process. Then facing think tank problems, we should start from the 3 orientations and focus on real problems to go through 4 research processes. Problem-oriented think tank research includes problem refining, analysis, integration, and solving. Evidence orientation on links of data, information, intelligence, and solution has different requirements. So does science orientation, which will be talked later. Then in the problem-oriented research, the link of data focuses on think tank problems and decomposes them into subproblems in terms of disciplines, which corresponds to problem refining. The link of information in the process sorts out and analyzes relevant data, studies the subproblems in depth, and then develops a preliminary solution. Intelligence in the process systematically summarizes preliminary solutions to subproblems and conducts comprehensive judgment based on experts' ideas. The link of solution means establishing solutions in different scenarios on that basis. The problem orientation, therefore, can guide the whole process of DIIS. Then problem refining can be understood as a DIIS process, which can be divided further into the definition, decomposition, checking of problems, and the determination of problems and technical roots. Problem definition pays attention to interdisciplinary integration and extension of multiple disciplines and fields. It collects data about problems for interdisciplinary research. It identifies the features of the problem according to the target, object, constraint, and demand, its key process, and the point cut to our research. On that basis, problems are decomposed. For defined problems, we should make clear the features like target, object, constraint, and demand to decompose them in terms of disciplines into subproblems. More full decomposition brings existing knowledge and academic accumulation to a better play. For every subproblem, we should make clear its key point. Problem checking after decomposition checks out whether problems are fully decomposed. Cognition is limited, so problems may not be fully decomposed, leading to false solutions in the following step. We should verify whether problems are fully decomposed to ensure comprehensive and scientific decomposition. Based on that, if lacking important data due to incomplete decomposition, we should return and make supplements and re-decomposition. So it is a mini process of DIIS. After that, it comes to problem determination to make clear problems worthy of research. Through analysis and decomposition, if we find a problem, or the major subproblem has been studied, with little room for innovation, we can just make a comprehensive analysis of relevant studies. That's what should make sure the value of research. At the same time, after this, we can find out the shortcomings of existing problems to know the key points and form a technical route of problem solving. To solve a think tank problem, we should first refine it. In fact, we learn the problem and convert the decision-related problem into a think tank problem. We grasp the overall features and decompose the problem to find whether and on what aspect the problem should be studied. We should first refine a problem rather than research it immediately, which may turn out to be meaningless. Problem refining is crucial to the subsequent research, so it can be considered as the process that converts a decision-related problem into a think tank problem. Such a scientific converted problem and the judgment on its research value control the overall quality of the research. It can be regarded as topic selection. We choose a specific problem and analyze it. Problem analysis is also a DIIS iterative mini-process. First, we should collect data and choose experts, which means gathering data about subproblems and selecting experts in relevant disciplines. With data and experts, we can explore subproblems, collate and analyze data about them, and then form a preliminary objective cognition. To solve subproblems, we conduct comprehensive analysis with the game method to combine different opinions, namely ideas of experts. We analyze stakeholders with the game method and summarize ideas of experts for the comprehensive judgment of subproblems to form a preliminary solution to the subproblems. Through comprehensive judgment, solutions to subproblems are formed, which is a process of problem analysis. On that basis, problem integration is made, which is highly dependent on the wisdom of experts. Preliminary solutions to subproblems are systematically combined in the crossover analysis to generate a final solution. Whether the research is scientific and comprehensive should be verified. We should make sure the comprehensiveness through comparison. If comprehensive, move on. If not, go back and repeat the process. So DIIS is an iterative and cyclic process composed of many mini-processes, such as problem integration. If incomplete, we should go back to the previous steps and repeat until it is complete. At least we think it so. Then, based on the collection of experts' opinions with the game method, we make a systematic and scientific analysis between stakeholders and combine experts' opinions for the comprehensive research, forming a process from subproblems to problems, which is a process of regression. In the fourth stage, after the completion of comprehensive judgment, faced with the future development, we may have different scenarios. Therefore, we should create a solution set of constraints consisting of different judgments on future scenarios. It can be seen that future scenarios are divided into positive, negative, and neutral ones in many high-quality reports. Then in the present trend, it's a neutral scenario. Better trend leads to positive scenarios. Worst trend results in negative ones. Based on the analysis and assumption of different scenarios, we provide the solution set in different constraints to form a preliminary report. In many existing reports, scenarios are incompletely analyzed. So we give different suggestions based on different scenarios. The quality standard is used to check the report. Reports up to standard can be generated, or else we should repeat the iterative process. Then a solution is given in the normalized format to form the final report. For the whole DIIS, its 4 links can be decomposed into 14 steps, including definition, decomposition, checking and determination of problems and root, research on subproblem set, integration and checking of research, comprehensive judgment, multi-scenario solution forming, quality checking, and report generating. Among the steps, there are some mini-processes like problem refining and problem analysis. In problem checking, research and quality are checked in iterative processes. Once incomplete, it will go back to the decomposition, integration, or even the first step, and go through iterative escalation in the helix structure. All this can help form the technical root of problem-oriented think tank DIIS. As mentioned before, in this case, the goal that China basically achieves modernization in the mid-21st century is the research problem. To achieve this goal, how should we develop science and technology can be answered in the strategic research, China's science and technology roadmaps, that depicts the future science and technology development and supports modernization. The research on that follows the whole DIIS steps. At the stage of problem definition, at first, we define the demand of science and technology roadmaps and identify the covered fields of the research problem. As mentioned before, the covered fields are divided into 18 fields. The field number was first 17 and then public security was added. For example, energy, resources, information, ocean, space, and so on all belong to the covered fields. For the characteristics of the roadmaps, because it's a long period of study, nearly 50 years in the future, we should describe its trend in the long term, direction in the medium term, and focus in the near term. This is the feature of the roadmaps. The demand means that the science and technology problem is formulated to address the faced targets in the modernization process. For example, In the field of energy, in 2020, 2030, and 2050, energy problems are linked to environmental problems. The capacity of energy emission to the environment determines that the energy emissions must be greatly reduced, and energy consumption should meet the demand of the environment. There is a total quantity demand for energy, which cannot be expanded indefinitely. So if we want to realize these conditions, we need to know which science and technology problems to solve. This is called demand and research fields. This stage is very important, and then according to the subfields of study, for example, energy can be divided into fossil energy, renewable energy, nuclear energy, etc. Fossil energy can also be divided into petroleum, natural gas, coal, etc. We can break the problem into subproblems, and then we are going to research these subproblems and whether these aspects are covered. In the aspects of energy, we take sustainable development, for example. There are many types of energy for sustainable development, and whether main aspects are covered, including wind power, solar energy, water energy, tidal energy, and geothermal energy, depends on whether they are worthy of being studied and whether they are important. And then we determine the subproblems and research routes based on this. So problem refining is very important. After the problem refining, we establish the research group. In each group, such as energy, we determine different research groups, which have different strategic structures. For example, the study of fossil energy and renewable energy. Petroleum is taken as a particular direction for research, because China is not rich in petroleum. On this basis, we research around the subproblems to collect policy intelligence, monitor domain intelligence, and build basic databases. For the subproblems, we analyze situations, scenarios, and future visions. The study of energy field also draws lessons from the research on 17 problems facing 2050 released by International Energy Agency to form solutions to subproblems. In the integration research, we perform subgroup research through group meetings, large group meetings, and a joint meeting of 17 or 18 groups. Through multi-round game analysis, opinion solicitation of relevant departments, and associative analysis, we can draw the roadmaps. For example, in the energy field, we draw 10 roadmaps, such as non-oil traffic and deep geothermal resource, facing 2050, 2035, and 2020. Finally, we proposed the solutions based on situations. You can read the whole report if interested. Actually, the think tank research with such a scientific research logic basically follows the 14 steps. This is the research process based on problem orientation. In the research process based on the evidence orientation and the link of data, the data should be reliable, which means that the data should be authoritative and verifiable. The source should be reasonable and the collected evidence should be sufficient. Besides, the data should be consistent, logical, and normalized. Otherwise, we may need to remove the noise in the data. The link of information under evidence orientation requires objective information. That is, the research process is free from subjective will, which is objective reflection. The information should be relevant and have a relationship with the present research. We should avoid outdated information. The intelligence under evidence orientation requires professional judgment. The most important is the selection of experts. The selected experts should have extensive research experience in the field. Without the experience, the insight is not enough. The comprehensive judgment means that we should combine multidisciplinary knowledge for judgment. The solution under evidence orientation requires feasible solutions that satisfy the actual needs and should be used properly. The solution should also be strict, logical, and scientific. They should be reliable, evidence-following, and effective. For the DIIS with science orientation, the link of data under science orientation should collect accurate data that conform to the facts and have no errors. The data should be reasonable, and the data samples should be representative and random, instead of extracted with a certain prejudice. The data should be complete, which means we should completely collect relevant data. In the link of information under science orientation, the information should be comprehensive, and we should integrate multidisciplinary information that is applicable to different conditions, methods, and scenarios. The intelligence under science orientation should have systematic judgments with the systems theory. We should perform independent judgment and avoid biased research due to funding relationships, which is very important. We should perform fair judgment and balance between stakeholders. In the link of solution under science orientation, the solutions should be ideological and have innovative ideas. The solutions should be forward-looking, and we should point forward a solution considering future development. The solutions should be scientific, robust, and persuasive. This is the relationship between the three orientations and four links. If we see from the research process and methods and tools, actually, we use different methods at different stages. The quantitative analysis has many methods at the link of data. The collection of network data, the retrieval tools of databases, etc., belong to quantitative analysis. In the link of data, we can perform questionnaire surveys, face-to-face interviews, and online interviews for qualitative analysis. Text clustering and information extraction can be regarded as comprehensive analysis. So we can see that the grids can be continuously filled, and we can develop new methods and tools as needed. Through them, we can select different methods and tools at different stages and ensure the scientificity. So when we research the think tank problems, appropriate quantitative analysis, qualitative analysis, and comprehensive analysis methods can support the systematic study in the four links. For example, quantitative analysis in DIIS research and the quantitative analysis of data, which I have mentioned before, will not be talked in detail. The collection of network data depends on software finders and other ways to grab internet data and processes the data again according to certain rules and standards. The retrieval of database includes literature data, patent data, and economic data. For the quantitative analysis methods and tools in the link of information, for example, the factor analysis method finds out the main factor, which is the concept value, to reveal the essential connection between things. The set pair analysis quantitatively describes the certainty and uncertainty of two things. The IBM tools are visualization tools for data selection, transformation, and mining. The SAS tools convert structured and unstructured information into values. For the quantitative analysis method of intelligence, the scatter degree method highlights the differences between the research objects overall, and it is a research method reflecting the overall difference between the research objects. The set-valued iterative method is to find a series of approximate solutions by initial values, belonging to the extension methods of classical statistics and fuzzy statistics. For the quantitative analysis in the link of solution, the multi-attribute decision-making method evaluates a group of selected solutions in a certain way, and selects the best alternative or ranks the solutions. The causal analysis finds the cause of problem, screens out important factors, and makes decisions according to the causal relationship of changes of research objects. For the qualitative analysis of data, we are familiar with questionnaire surveys, face-to-face interviews, and online interviews. In the qualitative analysis method of information, Analogy is very important. By analogical learning, we can find similarities and differences, the common law and key value through existing cases, thus obtaining a new understanding of the problem. For the qualitative analysis of intelligence, for example, in the game method, as mentioned before, the participants adjust their behavior by trying to figure out the psychology of other participants. And finally, the optimal combination of participants is achieved. The Delphi method just relies on the knowledge of experts and multi-round consulting to obtain a consistent judgment. For the qualitative method of solution, expert review is an example. In fact, many people sometimes produce expert review in one step. If the previous work isn't done, it's not enough to use this method alone. But if previous work is sufficient, expert review is also very common. Scenario analysis constructs different hypothetical scenarios and predicts the future possible situations and consequences, thus making the optimal decision. And there are a lot of comprehensive analysis methods. Actually, I believe in the think tank research, we should adopt more such methods as far as possible. For the comprehensive method in the link of data, text clustering and information extraction play a role of machine learning. Analytic hierarchy process in the link of information judges the importance between two indicators and establishes a judgment matrix to serve as the basis of evaluation and selection. The pattern map reflects the patent information of target technology through maps. There is also utility function method. For the comprehensive method in the link of intelligence, the science map is an example. It analyzes the literature and projects the results to the map, displaying the progress and the structural relationship of scientific knowledge. The trend extrapolation method, used frequently, is actually a comprehensive analysis tool. The comprehensive method in the link of solution includes fuzzy comprehensive evaluation, benchmark computation, which compares with the optimal object and finds out the aspect to be improved, and social network analysis that analyzes the structure and attributes of social relations through the graph theory and matrix method to get a visual diagram and find the key nodes. Then the methods and tools and the three orientations are actually related. During the research on think tank problems, we should choose appropriate methods and tools under the three orientations. That is to say, the selection of methods and tools is related not only to the four links, but also to the three orientations, such as the tool selection of quantitative methods, the analysis of evidence formation by qualitative methods, and the innovation of quantitative methods and tools. For the methods and tools based on the problem orientation, the think tank research should reasonably select the three kinds of methods and tools according to the problem characteristics. When the problem of think tank research conforms to the conditions such as specific, quantifiable, and clear concept objects, we can choose appropriate quantitative methods and tools. When the problem conforms to the conditions that the objects are abstract and can be textually described with fuzzy concepts, we can choose qualitative methods. When the problem has the comprehensive condition of quantitative and qualitative analysis, we can choose an appropriate comprehensive analysis method for research. Then for the methods and tools based on evidence orientation, we should use quantitative analysis methods and tools to form the collection, storage, extraction, and application of data information and other evidence. We use qualitative analysis methods and tools to form the intelligence, thinking logic, and cognitive outcomes of subjects and other evidence. We should use the comprehensive analysis methods and tools to form the cognitive judgment evidence, combining the objective information with the subjective understanding of the research objects. So, the evidence are different. For the methods and tools based on the science orientation, when the existing methods and tools of quantitative, qualitative, and comprehensive analysis cannot meet the needs of think tank research, they can be improved according to the methods and tools needed by the research objects to ensure scientificity and rationality. In Chapter 8 of our book, DIIS Theory and Methodology in Think Tanks, the judgment tool of the method for the innovation of source technology is completely developed based on the DIIS method, which is a comprehensive innovation method for identifying the source or disruptive technology. When we were studying the source technology of robotics, we found that none of the existing methods and tools can solve the comprehensive problem. So we developed source technology identification, which caused a great response when it was published internationally. Its citation has already ranked among the top 1 per 1,000. So we can see that the theory and methods and tools of DIIS offer a scientific guide for think tank researchers and the selection of tools in different situations. The methods and tools are applied to ensure the scientificity of our research. In fact, it also guides the innovation of them in the future think tank research, continuously enriching the methods and tools. The continuous innovation of research methods and tools also improves the scientificity of our research, so that the research can better get insights into the future and provide valuable solutions for decision making. That's all for today. Thank you.
Thanks to Professor Pan Jiafeng for his wonderful lecture. He discussed this theoretical model from the micro level and elaborated the basic connotation of this. From research process, think tank orientation, and methods and tools, he explored the general law of think tank research and gave the front view, top view, and left view. The research on this model systematically analyzed the research process of think tank problems, providing important scientific support for the think tank research in China.